In this video, I am going to solve the problem 23rd from chapter 19. So this is the last video for the problem 23rd, as we already make 4 videos for this question. So this question has 16 subdivisions. So here I am going to solve the last 4 subdivisions. By that, the problem 23rd will be over. Okay. So for more clear information, please see the previous 4 videos for this question. Figure shows a cycle undergone by 2 mole of an ideal monoatomic gas. The temperatures are T1 equal to 300 Kelvin and T2 equal to 600 Kelvin and T3 equal to 455 Kelvin. Now we have to answer for the last 4 subdivisions. So let's read what is given here. The initial pressure at point 1 is 1 atm, which is equal to 1.01 10 power 5 Pascal. So what they mentioned in this point 1, what is the pressure? The pressure 1 they mentioned as 1.013 multiplied 10 power 5 Pascal. So that means the value at the point P1 is given, right? Now for this we are going to find what should be the volume at this point. That means we are going to calculate the value of V1 also. V1 value already given in the question. So now we are going to find what should be the value of V1. So for that we have to use the ideal gas equation. What is the ideal gas equation? So now I am going to answer the M part. So for ideal gas equation we already studied PV, which is equal to nRT, and this time I'm going to make the equation as for the state 1, that for P1 V1, which is equal to nRT1. So this time I'm going to find the value of V1. Therefore V1 equal to nRT1 over P1. So now I'm going to substitute the value. N takes the value of 2 moles, which is given in the question, and the gas constant value is 8.314 multiply, and the T1 here is 300 Kelvin divided by, and the P1, which is already given here as 1.013 multiply 10 power 5 Pascal. Let's see what is the answer for V1 at the point 1. Clear? Okay. Therefore V1 equal to, let's see what is the answer. 2 multiply 8.314 multiply 300 over 1.013 10 power 5. So I got the answer as 4.924 multiply 10 power minus 2, and the unit for this volume is meter cube. So this is the answer for M part. So that means we found the volume at point 3, right? Point 1, sorry. Clear? Okay. Now we have to find what is the pressure at point 2. So let's see the figure again. Point 2 here, right? So in this point 2, we are going to find what should be the pressure in this point. Okay, if you want to find the pressure at this point, you have to see the figure from state 1 to 2. It's a straight line, right? That means in this line your volume is constant. That means V1, which is equal to V2 in this point, right? V1, which is equal to V2. Because why? Because the state 1 2 are in the straight exact straight line. So if you see the x-axis, there is no volume. So that means the V1 is constant. V1 and V2 takes the same value. So now by using this, I'm going to find the value of P2. So now I have to get the answer for the nth part. So what is nth part? So we are going to find the pressure at point 2. So for that again I have to use, so what is this? V1, which is equal to V2. So I am going to take the answer of V1 here, as we already find the answer in the M part, which is 4.924 multiply 10 power minus 2 meter cube. Okay, now again I am going to frame the ideal gas equation for the second state. Therefore P2 V2 is equal to nRT2, right? And we have to rearrange this equation in terms of P2, because here point at P2 is nothing but we are going to find the value of P2. Therefore pressure at point 2, which is equal to nRT2 over V2. Now I am going to substitute the value. N is 2 and R is 8.314 multiply, and the T2 value is 600, right? 600 over, and V2, because here V1 is equal to V2, so I can take the value as 4.924 multiplied by 10 power minus 2. So in place of V2, I'm going to use the answer of V1. So 4.924 multiply 10 power minus 2. So let's see what is the answer. 2 multiplied by 8.314 multiplied with 600 over 4.924 10 power minus 2. I got the answer here as 2.026 multiply 10 power 5 Pascal. So this is the answer for the pressure at point 2, right? Okay. Now we have to go back to the question because still we have two more questions. Find the volume and pressure at point 3. So you have to see this figure. We are going to find what should be the volume here, which is V3, and what should be the pressure here. Clear? Okay. For getting the volume, again we have to use. So in this place of 3, your volume V3, you can see this line from point 3 to 1, which is exactly a straight line. That means here the pressure P1, which is equal to P2, right? So in this case, your pressure P1, which is equal to P3. Am I right? Because in point 3 and 1 are in the straight line, that means this is a straight line, means your pressure is constant. That means the pressure at point 1, which is equal to the pressure at point 3. And I'm going to use this condition. Again, I'm going to deal with the ideal gas equation. So for getting the answer for the O part, what should be the volume at point 3? At point 3, that means we are going to find the value of V3. At point 3, your P1, which is equal to P3, and which takes the value 1 point, I have to see the constant here, 1.013 multiplied by 10 power 5, right? 1.013 multiplied 10 power 5 Pascal. Okay, now I have to write the ideal gas equation for the third state. So P3 V3, which is equal to NR T3. So we are going to find the value of V3. So I have to rearrange this equation. Therefore, V3 equal to NR T3 over P3. So N takes the value of 2. The gas constant is 8.314, and the temperature at the third state is 455, right? 455, which is given in the question, and P3, which is equal to P1. So I am going to use the answer for P1, so which is 1.013 multiply 10 power 5. So let's see what is the answer for V3. So V3, which is equal to 2 multiply 8.314 multiply 455 over 1.013 10 power plus 5. We got the answer here as 7.469 multiply 10 power minus 2 meter cube is the answer for the O part. Now for getting the answer for the part P, right? So what is the pressure at this point P? So you have to see the figure. We already find the answer. So at point 3, what is the pressure? Your pressure P3, which is equal to pressure at point 1, because it's a constant pressure in this line, right? So the answer for the P part, pressure at point 3, we are going to find, which is very easy. So P1 which is equal to P3, so you have to see the figure, okay? So P1 which is equal to P3, so it takes the value of 1.013 multiplied 10 power 5 Pascal, because this value for P1 is already given in the question. So that's what I take the answer directly, because for these type of questions you have to see the figure. Clear? So the answer for P3 here is 1.013 multiplied by 10 power 5 Pascal. So this is the answer for the last part. That's it. Thank you.